6.4 Part 6 talks about vectors in terms of magnitude and direction. So the magnitude of vector v with components of v1, v2 is given by the magnitude of vector v is equal to the square root of v sub 1 squared plus v sub 2 squared. And the direction theta is going to be the smallest non-negative angle that satisfies the tangent of theta is equal to v2 over v1, given that v1 can't be 0. So the formula v, which is going to be equal to the magnitude of v times cosine of theta times vector I plus sine of theta times vector j, will express the vector v in terms of its magnitude and direction. So don't freak out on this formula here, guys. You already know that cosine is associated with x, and x is going to be the first component, okay? So instead of putting the v1 there, they're going to put cosine. It's just like putting x. And then you already know that v2 is in the place of the y, and so sine represents y, so we're just putting it in its place instead. Alright, so let's try this in example 1. It says find the magnitude and the direction angle theta of the vector v is equal to negative 4i plus 3j. Round theta to the nearest hundredth of an angle. Alright, so first let's find the magnitude. So we're after the magnitude of v, and it's just like what we did before. It's going to be the square root of the first component squared plus the second component squared. And so we're going to work this out. And we find that our magnitude is 5. Then it also asks for the direction angle theta. Well, first let's think about this. So we know vector v has components of negative 4 and 3. So if I was going to draw this, angle here, I would have to go 4 to the left and 3 up. And so right here would be my terminal point. And so there would be my vector. And this terminal point would be negative 4, 3. Now I'm looking for the angle. So the angle is going to come from that positive x-axis here. So this is the theta that we're after, okay? Alright, so the formula tells us then that tangent of theta is going to be equal to our second component over the first component. Now, if we try to just use the inverse of tangent right here, think about it. Tangent is not negative in that second quadrant, but we know our angles in that second quadrant because of its components. So, we've got to find another way. And so to do this, we're going to use the reference angle. We're going to find, if we can find this reference angle right here, and I'm going to call it theta prime, then we know that we can subtract that from 180 to find what our actual theta is. Alright, so to find theta prime, we're going to take the inverse tangent of the absolute value and so that means that theta prime is going to be the inverse tangent of positive 3/4. And so we're going to plug this into our calculator. Make sure you're in degree mode. And this is not my actual answer, but I'm going to go ahead and go to the nearest hundredth, okay? And so we should get that this is approximately 36.87 degrees. So if theta prime is 36.87 degrees, remember then to find theta, we take 180 minus that theta prime,